Okay, we're going to explore a couple of things in this section. One, this idea of indirect proof, or sometimes you'll hear it called proof by contradiction. And the other thing, we're going to look at a couple of inequalities involved when you're dealing with two triangles. But first of all, indirect proof. And I want to illustrate how the indirect proof is used with an example here. Here I have a triangle ABC, and I want to prove that there are no more than one obtuse angles in this triangle. There's no more than one obtuse angle in this triangle. Okay, now remember, an obtuse angle is an angle bigger than 90 degrees. And I'm saying I want to prove that there can't be more than one. Now, here's the way we do an indirect proof, or it might make more sense to you to call it proof by contradiction. Because what I want to do is I want to take the contrary view of this, and then I want to contradict it. And so let's see what happens here. Let's assume that the measure of angle A is greater than 90, and the measure of angle B is greater than 90. Now, it doesn't matter that we chose A and B, just any two angles. And I'm saying any two angles. Let's just say that there's two of them, bigger than 90. It doesn't matter which one I choose. So assume that that's true. Then, if that's true, then the measure of angle A plus the measure of angle B is equal to, or is greater than 180. Okay, it's greater than 180. Okay, that's what happens. That's the natural conclusion that you draw with that assumption. That assumption that we know is not true. But measure of angle A plus measure of angle B plus measure of angle C equals 180 by the triangle sum theorem. Now, you don't have to say the triangle sum theorem. You can just say, because the angles of a triangle all add up to 180. Thus, we have a contradiction. Thus, the assumption that the measure of angle A is greater than 90 and the measure of angle B is greater than 90 is false. There, that's it. So we took the contrary approach. We said, okay, angle ABC, there can be more than one obtuse angle. And we said, okay, well, let's see if that happens. Let's see what happens if we assume that. Well, we found that it leads to a contradiction. Now, that is proof by contradiction, where you take the contrary approach. So you assume something that you know is not true, and if you can find a contradiction, then that verifies what you want it to prove. Okay, now there's a couple other things that we want to look at in this section, a couple of theorems. One, this Hinge theorem, and then the converse of the Hinge theorem. But look, you can read these theorems, but here's what it says, that if you have two triangles, notice I have this triangle and this triangle, and notice that two of their corresponding sides are congruent. So RS is congruent to VW, and ST is congruent to WX. Now, when that happens, when you have that situation, two triangles that fit that situation, two pair of congruent, two pair of the corresponding sides that are congruent. Okay, when you have that situation, the side opposite the larger angle is going to be longer. So in other words, we know right away that this side is longer than this side. Now that's if, notice, this side and this side match up to these over here and are congruent. Okay, that's if that happens. Okay, now the converse of that. Let's suppose that you have, once again, you have this side's congruent to this side congruent to this side, corresponding sides. Well, in that case, the angle opposite the longer side is going to be bigger. Okay, so if you look at that, so let's look at this. This side over here is 8, and this side is 7. Therefore, this angle right here, this is the bigger one. That's the winner. Okay? Now, this is the Hinge theorem and the converse of the Hinge theorem. Now, let's take a minute and use our new skill with indirect proof to see if we can prove this. So we've got two triangles here, and the qualifications are met, right? AB is congruent to DE, BC is congruent to EF, and AC is bigger than DF. Okay, now those are the things that are given and that are true. We can't change those. But the question is, does that mean that the measure of angle B is bigger than the measure of angle E? In other words, we're saying, is this angle right here bigger than this one? Well, let's assume it's not. Let's do this. Let's assume that the measure of angle B is not greater than the measure of angle E. Let's just make that assumption. And then if we can contradict that assumption, then we've proven what we want to prove. Okay, so let's see what happens then. Now there's going to be a couple of cases. Let's do this. Let's do case 1. Let's say that the measure of angle B is equal to the measure of angle E. Okay? So, this is case 1. Now, if that happens, then the triangle DEF is congruent to the triangle, let's see here, the triangle ABC by side, side, side. Okay? That's what has to happen. However, we know that AC is bigger than DF. So that can't happen. If those triangles are congruent, then AC has to be congruent to DF. Okay? So that doesn't work out. Now let's look at case 2. Case 2, we're going to say the measure of angle B is less than the measure of angle E. Okay, let's see what follows from that. Well, if we make that assumption, then AC is less than DS. Okay, and that's by the Hinge theorem. Okay. So if we make this assumption, so that's it. If we make this assumption, then we see that it just leads to contradictions. Therefore, the opposite must be true. In other words, if the measure of angle B not greater than the measure of angle E can't be true. In other words, we assumed this to be true, and we said, okay, what does that imply? Well, that implies either case 1 or case 2. If it's case 1, there's a contradiction. If there's case 2, there's a contradiction. So what we've done is we've proven that if this were true, we would just get contradictions. Therefore, this must be true.